Hello everyone, it's good to see you all over again. I'm Natasha and welcome back. So today we're gonna continue our chapter 4. It's mathematical induction. Yeah, it's principle of mathematical induction. So today we're gonna discuss a question, and I've already written the question. So before solving this question, I want to tell you that in the previous video we also solved the question, and in this video again we'll be solving the question, and in the next video maybe I think that I don't know what will we do in the next video, but let's just forget about it for now. So all we have to do is right now is just to solve this question. So let's discuss this question. So let's get started. Okay, so this question is really short, and what we have to do is we have to use mathematical induction as it's a practice question of that topic. So prove that 2 to the power n is greater than n for all positive integers n. Okay, positive integers, which means the positive z. Z is for the set of integers, so positive z, only including, so it's like only including the positive integers, not it's only including the non-negative integers. So which means that there will be no negative integers. We have to just tell that the 2 to the power n is greater than n for all positive integers, not the negative integers. Okay, so first method, as we all know, we're gonna have a look at the base step. So we're gonna do the base step first too. So the solution, what's going to be the solution? So the base step is in which we're going to, prove that, that statement, this given statement is true for the initial value. So we're going to say that, let's take a base value. So smallest base value, I'll say 1, okay? So I'll say 1. Got it? So, but yeah, first I'll say P of n. As we're proving it, so I'll say P of n. Okay. So P of n is equal to 2 to the power n is greater than n. Just have a look. So this is going to be our base step first. Got it? So what I'll say is we're actually we're just assuming it. So so let's take it in an easy way so that we'll not be confused. So I'm going to say this: let P of n be 2 to the power n greater than n. So that's what we're saying, isn't it? Okay. So let P of n be 2 to the power n greater than n. Okay. So 2 to the power n is greater than n. Okay, that's what we're having. So it's P of n. Got it? So, second thing is that which values are we getting? So we're going to get, so first of all, let me write P of n, okay, as we're solving the P of n. So, for the value of the n, so this n is our, the main thing that we have to do. So what I did was the base step. So let's talk about base step now. So what else is that this n is equal to 1, as we're going to start from the smallest base value, and this I'm having 1, okay, just as the smallest base value, okay, yeah. So it's gonna be which way should I write, just as a simple or something really confusing? Of course, I'll be not writing confusing things. Of course, I'll be not writing anything that will confuse us. So yeah, so I'm gonna say this when, let's take it in an easy way. So when n is equal to 1, 2 to the power n is greater than n. Okay, one thing that we're seeing, actually we have to prove this thing, got it? And we'll prove it by doing the base step and the inductive step. So by just having a look at those two steps, and then we'll get the answer, okay? No, actually we're not we're actually going to get the solution. So I didn't mean the solution by something else. I just mean that through those two steps, we'll be able to prove it, okay? That we have proved it, and that's it. So what we're so in the end, what we'll write is that this statement is true for like the given statement as it's saying that for all positive integers n. Got it? Okay, so what we can see is when n is equal to 1 as a base value and 2 to the power n is greater than n, okay? Okay, so what I'll say is p of n is true. Now I'll say p of 1. So as I've taken the value n as 1, so there's no problem in it. So p of 1 is true. Okay, now I'll say this. Got it? Now the next step I'll do is p of 1 is true, so as we all know, so the next step is going to be our induction hypothesis. Yeah, which is actually the part of inductive step. So we're going to do the inductive step. So in the inductive step, we're going to take a value p of k, okay? Yeah. There's one thing is confirmed that p of 1 is true, okay? So, yeah, one thing like, I did something wrong here was that I actually wrote it the same way. I didn't even, wrote the value of n. So I'm going to do it again. So when n is equal to 1, so at the place of n, like 1 will come. So 2 to the power 1 is greater than 1. Okay, this is the correct form, okay? Get it? Yeah, so 2 to the power 1 will be 2 and 2 is greater than 1. So which I'll say is p of 1 is true. Now this is going to be right. You know, and that way like you'll be a little confused. So I forgot to write the value of n. So now it's going to be like clear to us, okay? Yeah, so p of 1 is true as we're seeing that that 2 to the power n is greater than n. So this is base step true. Now let's move on to inductive step, in which we're going to take the value p of k, okay? P of k. So what's the p of k? So k is actually, it's just a, it's just for, the all, like we had all the positive integers. So it's saying we have to prove 2 to the power n greater than n for all positive integers n. So at the place of n, I'm just going to put k. So it's going to be for all positive integers k, okay? So I've just taken k at the place of n. So it's going to be, so it's going to be p of k. So we're assuming that p of k, is true. Okay? So we're assuming p of k is true. Now what we'll do is, for the positive integer, that is k. So let me write it. So what is it true for? Okay, so we're assuming p of k is true for any integer k. Okay, now have a look. I think that will be clear to you, all of you. Okay, so assuming p of k is true for any integer k, and the next step that what we'll say that 2 to the power k is greater than k, at the place of n. So what I'm going to say is 2 to the power k is greater than k. Got it? So the next step is for the k plus 1. So is k plus 1 going to be true? And if that's going to be true, that just means that we have proved it. That's it. So now the next step is for the 2k plus 1, okay? So 2 to the power k is greater than k, and now it's the turn for k plus 1. Got it? Because we have to check, is it true for the next positive integer, like the positive integer, I'll take 1. So is it true for 2, 3, 4, 5, 6, and all the other positive integers? So that's what we're going to check from the 2 to the power k plus 1. Got it? So what I'll do that, I'm going to multiply both the sides by 2, okay? Just like, so what I'll get at its place, like on multiplying both the sides. Multiplying, let me write it in just a small statement. Multiplying both the sides, it's actually sides, so multiplying both the sides by 2, what do we get? We get, so I'm going to multiply 2 by 2, so it's going to be 2.2 to the power k is greater than 2 to the power k. Got it? Just have a look. Isn't it correct? Okay, so it's absolutely correct, and now we're gonna just finally look up for our value 2 to the power k plus 1. Got it? Okay. So what are we waiting for? Let's just solve this question, as it's really becoming it has really become a piece of cake for. So let's just eat it and finish it. That's what we're gonna do. Okay. So what I'll say is, now 2 to the power k plus 1. Okay, so it's 2 to the power k plus 1. Got it? So 2 to the power k plus 1 is greater than 2 to the power k. That's what we can see, okay? That's what we can see. Got it? This is the one thing that we're always going, there will always not for always, but for now we're going to remember this. The 2 to the power k plus 1 is greater than 2k. So what are we going to get? It's really simple. So it has become k plus k, and k plus k is greater than, what is it? K plus 1. Isn't it? Okay. So k plus k is greater than greater than k plus 1. So what I'll say is, okay, so let's take a small example, okay? So let's say that the value of k is 2, okay? Let's say this. So 2 plus 1 will be 3, but at this side 2 plus 2 will be 4. So what I'm saying is 4 is greater than 3. So like, this is how we get it. And this is the easiest way to solve this question, that it was really short, just have to write some few things and we're done. Okay, we're totally done. So what I'll say is P of what? P of n is true for all positive integers n. Got it? Okay, so therefore P of n is true for all positive integers n. So P of n is true for all positive integers n. Okay, so don't get confused. It was just a really easy way. So it was 2 to the power k plus 1 is greater than 2 to the power k. So the way we solved the previous question was, I just took that same method, in which we solved a lot of things like k plus 1, k plus 2. Wasn't it like this way? If you remember it, I hope you haven't forgot it, because it was just it was just a previous video. Yeah, so k plus 1, k plus 2, so it was just like this way, and what I did was, just solved it like a different way, like through the way we get k squared upon 4 plus 4, and then we got k plus 4k, something like this, okay, something like this. I don't exactly remember it, so it was something like this. So just like the way you solved all these things, the one by one, I just did the same thing right here. Okay, so there's no problem in it. Good? Okay. So let me rub this, because there's no need to write this thing. This is not related to this question. Okay, so what we can see is it's true for, I can also say it's true for every positive integer n. So let me write this, because it will be more, better than this one. Yeah, but it's actually also correct. There's nothing wrong in this, but I would like to write another one. So it's true for every positive integer n. Okay, that's good. Oh yeah, we can also write for all positive integers, but doesn't mean doesn't matter to the statement, as we had to just only prove it, and we did it, and that's it. So you can even write this only this thing, okay? But I just wrote like this, because that doesn't matter at all, okay? So, that was just one question, as I told you. Yeah. So, as I told you that we'll be just, solving only one question. So, that's all for today, and I hope you've understood everything, because there was nothing hard in it. Like, we solved this question really easily. So, we have finished it. Just like, I don't know, well, what should I say, but, so we've just finished it. So, thanks for watching, and, about the next video will be, I think maybe, like, probably will be, solving some questions related to this chapter, or we're gonna do a new chapter. Maybe that's gonna be chapter 5. So it's gonna be the 5th chapter, which is complex numbers and quadratic equations. Oh, that's a really interesting chapter. So we'll soon discuss it. So have a great day.